Hello friends, in the last lecture we have learned about the different type of power plants, how many types of power plants are there, and as well as the exponential growth of electricity. Now in this lecture we will be learning about the term called as load duration curve. So before we start about load duration curve, you should understand that when someone want to build a power plant, so what parameters he should be thinking before developing or before constructing that power plant, before building that power plant. So these parameters are basically two. The first one is the total power output which he want to install, the total power output, power output to be installed. This is also called as kilowatt installed. And the second one is basically the size of generating units. Now here you should understand one thing very clearly. The total power output means the power output from a full power plant. You can think this as a full power plant. Now inside this full power plant there are several different units. What are these? These are basically the power producing hubs. These are the individual units, means the portion where the electricity is produced. So there are, so what has been done, we do not install, let's say I am interested in installing a power plant having the maximum installation capacity of 500 kilowatt. But what I'll do, I'll not do this. I'll not install a single plant. What I'll do, I'll install these semi plants. Let's say what I have done, I have installed 4 plants of 100 kilowatt capacity. You know what is the benefit? The benefit is, several benefits are there indeed. The first one, let's say if this power plant fails due to some reason, then we are still supplying 300 of kilowatt of electricity. Not only this, let's say our power plant was expected to supply only 300 kilowatt of electricity. Then what is the use of this? This will act as a reserve. So if this power plant, if this particular unit or the small portion of the plant goes for maintenance, then we can start this. So the power plant installation capacity is one thing. That means the total generating capacity of the whole, whereas the individual parts which produces the power and that sums to this, they are what we call as the generating units. So how the total installation capacity of a power plant is decided? The total installation capacity is decided by the first, the estimated demand. That is how much the demand is going to be in future. That is what we call as the maximum one. And apart from this, what is the growth rate, or what is the estimation that this much amount of power will grow in future? So basically growth of demand, how much amount of electricity is going to be required in future. So future, we have to think in future also, because let's say I am only developing a unit of 500 kilowatt, okay, but in next 5 years or 6 years the requirement goes from 500 to let's say 700, and I have already built the whole setup, and it cost a lot to increase it. But to, if I am starting it from zero, then in less time as well as in money everything can be done. Not only this, once you are thinking of the installation capacity, you also have to think of the reserve. That if my power plant is supplying, let's say, 300 kilowatts of electricity, then I should have that reserve, that minimum reserve. In my case, what I have taken as 100. So that reserve will fulfill so many criteria that while during maintenance this will work, and if something fails, so again this will come into picture. So the reserve capacity has to be there, not only from this point but from the point of view of demand growth. Okay. So now the size of generating unit. So how do we decide the size of these individual generating unit? So the first and the very important criteria is the load variation. In 24 hours, or maybe in month, or maybe in year, or the load variation during the winter time, the summer time, and so on. Apart from this, the size of generating unit is also decided by the uh, total capacity of units connected to the electric grid. So units connected to the total capacity of units connected to the grid. Now, what is a grid? Grid can be thought of as a sink where everything falls, where every power plant dumps its power. Okay, so how many individual units are connected to that particular grid? So, based on that, also the size of individual unit is evaluated. Then, not only this, we should know that what is basically the starting time, ending time, means in how less time a particular unit can be started. So basically it is called as startup and shutdown period. Startup and shutdown period, okay, of a particular unit. And if we are setting up a power plant, we should also set up our maintenance plans, है ना? So maintenance plan. So this also comes into picture whenever we are interested in setting up a unit. Okay. And others also, that what is the price and space demand for every kilowatt of power production from the unit, and efficiency of a particular plant with respect to the unit, and so on. So there are so many factors, and out of these factors, what I said, this is a very important factor: load variation. So basically, this is something which you should understand, and it is a very, very, very important tool, uh, because this helps us in knowing the basically the anatomy of power consumption. So what we say, that how much, or the estimation of the maximum load, or the variation of the load over a period of time, is something which we call as load duration curve. So consider this. This is time. It can be spanning over days. It can be spanning over hours. Doesn't matter. And let's say it is the kilowatt. So this particular variation is what we call as the load duration curve. So let's say it is starting at 12 a.m. and then 12 a.m. So let's say here it is somewhere 12 p.m. So that is how the variation happens. In the morning, the load will be less. In the around 12 p.m., it will be maximum, and then it will be reducing. Then in the evening time, again it will be increasing, and so on. So this variation should be very much clear. Not only this, apart from this, one should also know that what is the average value of it, and that average value is what we call as average load, as well as the peak load, because they are very, very, very important to for any power plant coming into picture. Now once the load duration curve is ready, then how to study it? So there are several factors which helps in studying or understanding the nature of demand. So the first one and the very important one is what we call as the load duration curve. Load factor. Load factor is normally represented as M. It is the ratio of average load to that of the maximum load or the peak load. The average load means the area of this particular diagram to that of this peak load is what we call as the load factor. The more the value of this load factor, the better the plant is loaded, means even power production throughout that particular time period. And if the load factor is very small, that means the power which the power plant is giving, the generating, the power plant is not working up to its full capacity. It is not working in a good way. Most of the time, the power plant is underutilized. So it is basically telling you about the utilization of a power plant, how much effectively the power plant has been utilized or it is generating power. Now, basically, the average load over a given interval to that of peak load. So how to find out the average load? You just evaluate the area and then divide it by that particular time period. So that is, so if I take it, if it is in kilowatt and this is in hour, so the kilowatt hour, that is the area, divided by that particular time period. So if I am talking of let's say yearly load factor, then I have to divide it by 365 into 24, that is 8760 approximately. And then this is the peak load, that is the maximum load, that is kilowatt maximum. So that is how load factor is evaluated. Again, the average load to that of peak load during a particular time period. Now, once this is clear, then I should also know about the capacity. So there comes the capacity factor, represented as N. It is defined as the average load to that of plant capacity or rated capacity of plant. What does I mean by this? So here, let's say the peak load is 200 and the plant capacity is 250. So in that case, I will be evaluating the average load and then dividing it by not the peak load but the capacity. Okay, so it is defined as the average load upon rated capacity of plant. So what is average load? It is kilowatt hour divided by 8760 divided by kilowatt maximum. Again, I am telling you this is for year. Okay, if the plant capacity or the rated capacity of the plant is equal to the peak load, that is kilowatt maximum, sorry, this is plant capacity, so it should be, oh, let me delete it. So it should be capacity, installation capacity. So sometimes some people also write it as INST, means installation capacity. So if the maximum load and the installation capacity on any plant is same, then the load factor and the capacity factor will be equal. And this difference between the installation capacity and the maximum capacity tells you about the reserve which is there with the plant. That means how much more the plant can be produced. So here comes another factor called as reserve factor. Represented as R. It is the ratio of the load factor to that of the capacity factor. So the load factor is M, the capacity factor is N. So if you apply these formulas, that is load factor upon capacity factor, so average load and average load will cancel. This plant capacity will come in the numerator and the peak load will come in the denominator. So this is nothing but the kilowatt installed to that of kilowatt maximum. Okay, now if this factor is more, normally it should be more, let's say it is more than 1, but if it is, let's say 10, that means what? That means the maximum capacity is 10 times lesser than the installed capacity. So again, it is not a very good sign. Okay. Apart from this, if you consider a particular consumer, let's say consider yourself. In your house, there will be several electrical appliances like refrigerator, air conditioner, fans, tube lights, normal bulbs, your laptop, there's so many things. Okay, geyser. So if you add up the total, that means the total wattage consumption by each and every component or the appliance in your home, then that will be summing up, that total is what we call as connected load. Connected load. That is the total load. Total possible load is what is called as connected load. Okay. But at any time we don't run every component whatsoever is there. So that particular one is called as maximum demand at any time. Okay. So connected load will always be more than the maximum demand because we are not running every appliance present in our home at a particular time. Okay. So demand factor, something is coming into picture now for a particular type of consumer, and that is basically the actual load to that of total connected load or connected load. So this is nothing but kilowatt maximum, and this is kilowatt connected. This denominator is the sum of all. Okay. Now this is for a particular type of consumer, but there are so many types of consumers. Let's say industry is one type, or hostels are another type, or village is one type, and so many. So if we try to plot the load duration curve for different types of consumers, let's say this is 1, this is 2, and this is let's say 3, and let us try to find out the peak. So let's say the peak for this is A, the peak for this is B, and the peak for this is C. What is this peak? This is basically individual consumers maximum load. So if we do what? If we try to find out if we sum up everything here, everywhere, and then try to find out that particular peak. Let's say that peak I am getting, let's say here. So this is something which I am getting as the peak. Okay, and this is, let's say, D. Then the diversity factor for different consumers will be the sum of the individual consumer groups. That means A plus B plus C divided by the actual peak load for the whole system, that is D. Okay, this is what we call as the diversity factor. And now comes the last factor which I remember right now, and that is what is called as plant use factor. It is denoted by U. Okay, now what is a plant use factor? It is basically the ratio of energy or electricity produced in a given time. Okay, and that is what we call as the electricity generation, and that you have already seen here. This kilowatt hour, that is what is called as the electricity generation in a particular time period. So that kilowatt hour generation in that time period divided by the maximum possible energy that could have been produced during the same time. Now maximum possible means based on kilowatt installation and that time period. Okay, so what is called as operating hours. So if I am having a plant having, let's say, the installation capacity of 250 megawatt, and my plant is running, I am interested in knowing that what is the total generation in a year, then or in a certain time period, let's say 200 or 300 days, then so if I obtain the area under that particular load duration curve, so that will be my numerator. and I have to divide it by that installation capacity, that is 250, and then multiplied by operating hour, that is, let's say it is 300, so it is 300. So operating hours will be 300. So what is the importance of this use factor? This use factor will tell you that how many hours or how many days or how many months your plant is not working properly or it is not producing any power. So this is a very important factor when it comes to the power plant. Okay, so now you know about the load duration curve, that is the variation of a load R by R. And from this load duration curve, what people do is people generate load curve. How? So if so, let us see here. So let me copy this full. Oh, I think it has not been copied. Very bad. So let us draw it again. So let's say this is my load duration curve. Okay. And from here, if I find out that this is the peak, so this is the value, then comes this value, so my curve will go like this. Then this, basically time is also in there, time is also coming in the picture for how much time this particular load is there. Then this one, then it is moving like this, then this, and it is falling like this, and so on. So from load duration to load curve, I move, and that gives me the value of basically this load duration curve indicates for how many hours a certain load has been required. Okay, and this helps us in evaluating or computing the number of units for any plant. Because what we can do is we can break this load curve. From here it is very difficult, but from here it is very simple to understand that what we can do is we can break this into several parts, primarily three. That is this one, then let's say this one, and then let's say this one. So there are three regions. Now what are these three regions? The first one is telling you about the peak load. This is your base load, and this one is what we call as the intermediate load. So base load, peak load, and intermediate load. Basically the base load is that particular load below which the electricity demand never falls, and the peak load is basically that load which occur only for the 15% of the total time, and the remaining one is what we call as the intermediate load. So now it must be little bit clear to you that if I am having a certain plant or I am thinking of a certain plant, then the individual unit should not have a load below than that base load. Okay, so that is how this particular load curve is important. And when you think of a plant, there are several factors for selecting a site. Basically, if you are thinking for a power plant, then you should be having ample amount of water availability. You should be having fuel availability, and the load demand should not be very far from your power production. And because you are thinking of, let's say, a thermal power plant, then coal is the primary fuel. So there the wind direction also plays a very critical role, because you have to pile up the coal in coal yards. Okay, so as well as apart from this, so once coal is burned, so ash is left. So proper disposal of ash should be there. You should also think in your mind, and then you will be planning some facility for your workers. That means a residential facility. So The connectivity from road should be good, and proper schooling for the kids of residents should be there, and so many factors you have to think. Okay, so now in this lecture till this point only. In the next lecture, what I'll do is I'll take 2 3 problems which can make you little bit more comfortable with the load curve, load duration curve, and this different factors. Okay, so thank you very much for watching it. We'll meet in next lecture. Take care.